This is review problem number 9. And we're going to go through these A through H a little faster than the previous videos. So if these look confusing, maybe go back to the start of those other videos and I spend more time going through these. But by now, we should have a pretty good handle on A through H. So let's just figure out our degree here. Again, we look at our largest term, and we want to just look at the exponent for that largest term. So that's going to be 3. Our leading coefficient here, again, is a positive 1. Our end behavior, it's actually the same as the last few problems, because for end behavior, we're only looking at our dominant term, which is going to be our highest degree term. And so at minus infinity, this is going to tend towards minus infinity. And when x gets big in the positive direction at positive infinity, y is going to go to positive infinity.
What?
Okay, and again, we're going to get a real root because anytime we go from minus infinity to positive infinity, we have to go through the x-axis. The maximum number of roots we have for a third-degree polynomial will be 3. Again, we don't know how many this one has yet, but we know it has a maximum of 3 when the degree is 3. The maximum complex or imaginary roots, I'm using these terms probably a little too much interchangeably. Again, complex is when you have a real part and an imaginary part. So here our max would be 2. Again, because they come in pairs, you could only have 2. 4 would give you 1 more than your maximum number of answers. Turning points, the max turning points is 2. Again, that's always the degree minus 1. The y-intercept here is a minus 6. If we put a 0 in, all of our x terms would go away. So when x is 0, y is going to be negative 6. And then our possible rational roots. Well, here we're going to have to spend a little bit of time on this one because we'll see factoring is going to depend on us having those. So we have a 1 on our leading coefficient, and our last term here, our y-intercept, is minus 6. And so to figure out our possible rational roots, we need to think of all of the factors of 6. And those are going to be 1 and 6 and 2 and 3. Now what's nice here is these all would be our numerators, and their denominator would be all the factors in front of the leading coefficient. But here our leading coefficient is just 1. So you could think of all of these over 1, but we don't need to write that, right? Anything divided by 1 is just itself. So our possible rational roots are going to be plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3. And a lot of times it's nice to put these in order. These are all nice integer that I have to deal with, so it's not that big a deal. But if you have a lot of fractions, it's nice to put them in order. Not necessarily in order from smallest to largest, but in order from the easiest to the hardest to put into the equation. So 1 is always a great one to start with because if it works, it's easy. Okay, now we have to look at our roots or x-intercepts. We want to figure out what those are. And that's going to be, hey, what values of x? So if I have x cubed plus 2x squared minus 5x minus 6, what values of x would give us 0? Those would be all of our roots. And we could have up to 3 in this case. Okay, so in our last problem, we factored by grouping, and that was successful. But in this problem, if you look here, yeah, I've got a common x squared term. If I factor that out, I'm going to be left with x plus 2. Here, the only thing in common is a negative 1. If I factor that out, I'm going to get a 5x plus 6. I won't get a common factor. So factor by grouping isn't going to help me much. It's a good thing to look for because if it's there, it makes the problem a lot easier. But in this one, we're going to have to actually use the factor theorem. And what we're going to do is we're going to try some of these answers. So what I like to do is try our easiest one first. and that in this case would be 1. So let me go to blue here. Okay, so if we plug in a 1 for x, right, it's just no matter what happens, it's going to give us a 1. And so we would have a 1, this would go to 2, this would be a -5, so this would be a -5, and then we'd have a -6. Well, that's not going to give us a 0 over here. And what we're doing with all of this, we are using our factor theorem. It tells us, hey, if I can find a value of that, let me fix our exponent here. If I can find a value for x that goes in there, then I can say, hey, whatever that value is, let's call it a. If I find a value of a that renders the function to 0, then x minus a is going to be a factor. And we can use that to help us do some division and simplify the problem and factor it down further. Okay, so 1 did not work. Let's try -1. So if I plug in a -1 here, get a -1, and a -1 squared is a +1 times 2, so that would be a +2. A -1 times a -5 would give us a +5, and then we have a -6. Well, this is looking promising because a -6 and a -1, that gives us a -7, a 5 and a 2 gives us a +7. So we know that x equals -1. X equals -1 yields f of x, gives us f of x equals 0. So we can say f of -1 equals 0. That's one of our roots. Okay. So now that we know that, we can say, hey, x plus 1 is going to be one of my factors. So let's do some division. I don't need all of this stuff here. So let me get rid of this. Okay. We know x equals -1 is one of our solutions. So we're going to divide by x plus 1, and x cubed plus 2x squared minus 5x minus 6. Now, I have a nice linear term here, a nice binomial with a 1 in front of the x. So that tells me I could use synthetic division if you want to. If you want to do that, go for it. I'm going to use long division, and you know I like it better. Okay, I'm going to start with my x squared. And the reason I put an x squared there is because if I know I multiply my x squared term times x, that gives me an x cubed. And then I multiply the 1 by the x squared, and that gives me plus x squared. Okay, now I'm going to change the signs and add rather than subtract. So 2x squared minus x squared gives me an x squared. And I'm going to bring down my 5x. And then now I want to think what goes up here is going to be what times x plus 1 will give me an x squared term. So that's just going to be x. So x times x is x squared, and then x times 1 is just x. So that'd be plus x. Okay, so now I'm going to change the signs and add, and that gives me a minus 6x minus 6. Look at this. It's all coming together. And then so I can make a minus, put a minus 6 up here. Minus 6 times x is minus 6x, and minus 6 times 1 is a minus 6. And look at that, I get a remainder of 0. All right, so math is working today. Okay, so now I know that I did my division, and that tells me that x plus 1 times x squared plus x minus 6 equals 0, right? Just like if I divided 21 by 7, I would get 3, and that tells me that 3 times 7 equals 21. And we did the same thing here. We divided this big polynomial. We divided this big polynomial by x plus 1, and we got this. So we know that x plus 1 times x squared plus x minus 6 is the same thing. We've just broken it down into two factors. Okay, now we know if from our zero product property, we know that this term is going to could give us 0, or this term can give us 0. So we've already know the root here. Now we're looking for roots here. And hopefully that you'll notice this is a quadratic. And I have a feeling we are going to be able to factor this one. We could try, if we're not sure if we can factor it or not, we could try the discriminant. But here I think this is going to work looking at this, because I know the first terms have to be x, and I'm going to need to get a positive 1 in the middle. So I think a positive 3 and a minus 2 are going to work. And again, if that looks confusing, we can multiply it, FOIL it out, and make sure that we get to where we started. And we would in this case. Now this is a really nice factored quadratic, because I can look right at it and say, hey, x equals 2 is one of my solutions, and x equals minus 3. That would also be another solution. Minus 3, make that a little neater. Okay, again, plug in a minus 3 for x. That would give me a 0 here. I multiply it by whatever else, I know I'm going to get a 0. Same with the 2. Okay, so I have, in this case, I have 3 roots. I have x equals minus 1, a 2, or a minus 3. And we can put those in order. Let's go ahead and take the time to do that. Minus 3, minus 1, and 2. Now the nice thing there is we get these nice real roots. So we should be crossing the x-axis at 3 different places. So let's look at our Desmos. And indeed, this is our Desmos graph. And hey, math is working today. Okay, we have a 2 and we have a minus 1. I know it might be hard to see the scale there, or a minus 3. So minus 3, minus 1, and a positive 2, just like we have down here. So Desmos is confirming that, hey, we got the right answer. Again, notice that this has 2 turning points. And right, so this does have its maximum number of turning points, and it crosses the x-axis in 3 places. All right, keep working and the answers will come. Good job.